Hello, Matthews Gatos here. In this video, we're going to cover graphs of relations and functions. So let's get started. In our last video, we looked at arrow diagrams, and arrow diagrams are a way of showing relations. It's showing how elements in set X are related to elements in set Y. Let's look at our first example. You can see that the arrows go straight across. So -2 only goes to -4. -1 only goes to -2, and so on. These are called one-to-one relations because one element in X goes to one element in Y. In this next one here, you can see I have some doubling up. I have two X values that go to -1. I have two X values that go to 0. So I have many X values going to only one Y value. This relation is called many to one. In the last example, you can see I have one X value going to many Y values, one X value going to many Y values. This is called a one-to-many relation. Now those elements in the first and second set have a special name, and that's called domain and range. So domain is the set or the elements in the first set. It's the independent variable. If I were to graph this with coordinates, it would be the X, the first number in the ordered pair. Range is the second set of elements in a relation. It's the dependent variable. If I were to graph that with the coordinates, it would be the second number or the Y value in an ordered pair. Relations have domain and range, and how domain and range are related determines whether it's a relation or a function. Now, a function is a special relation in which each element of the domain has only one element in the range. That means one X value goes to one Y value. So how we recognize functions, we're going to look at this in a couple of ways. The first way is ordered pairs. Now, one-to-one and many-to-one relations are functions because the Y values repeat. One-to-many relations are not functions since the X values repeat. So if you ever have a repetition of the X values, that means it's not a one-to-one relation or a many-to-one relation. For example, we want to know, are the following functions? So if I look through here, I can see that I have no repeated X values. Since I have no repeated X values, I can say this is a function. 1X goes to 1Y. In the next example, can you see how I do have some repeats? I have a couple -1s. So -1 is not going to one Y value, it's going to many Y values. So this is not a function because there are repeated X values. How do we recognize if it's a function from a graph? Well, remember, each X coordinate can only have one Y coordinate. So what we're going to do is slide a vertical line along the graph to check each X value has only one Y value. How it works is this. If a vertical line touches the graph only once, I can say it is a function because it passes the vertical line test. However, if the vertical line touches the graph more than once, then I say it is not a function and it therefore fails the vertical line test. Let's look at an example. So I want to know, are the following functions? So what I'm going to do is slide a vertical line across here and see if it touches once. So only touches once, once, once. So I can see in this example, for every one X, there is only one Y. So this is a function. It is a function because I can say it passes the vertical line test. Okay, let's try the next one. So I slide a vertical line along and I see, uh-oh, right there, it fails. It can only fail once. It can fail multiple times, but if it fails even once, you can say it is not a function. So this is not a function because it fails the vertical line test. So you've seen now how to do that with coordinates and how to do it with graph. So anytime I have a repeated X value for the same Y value, it is not a function. Now let's talk about two types of data. So we're talking about elements. Let's talk about the type of elements that we can have. We can have discrete data. This is data where the in-between points are meaningless. So it's shown by individual points. It's individual points, so domain and range have individual points. When I think of discrete data, I just ask myself, does it make sense for me to have half of this? So if I'm talking about a word problem, for example, I'm talking about maybe the number of people. I can't have between 1 and 2 people. I either have 1 or I have 2. There's nothing in between. So the in-between points would be meaningless. That would be discrete data. Continuous data, however, is where the in-between points make sense. They're meaningful. Graphs show continuous data with a line. So domain and range will be an inequality. It will be a range of values. An example of continuous data would be, for example, money. I can have between $1 and $2. Or temperature, I could have between 20 degrees and 21 degrees. The in-between points make sense. That would be continuous data. So if we put this all together, domain, range, continuous, and discrete data, let's talk about how that looks. Now, I'm going to look at all the scenarios that I can have for graphing. It's either going to be the graph is below a number, above a number, or in between two numbers. So you see here I have two examples of below a number. Now it is continuous data because it is a solid line. So if I have continuous data where it's below a number, let's talk domain. Domain is x, and we look where x is. This endpoint here has coordinates of 5 and 7. So that means all of my x values are less than or equal to 5 because it's going down to the left. My y value for my endpoint is 7. So that means it's everything less than or equal to 7. Now I can write that as an inequality, or I can write it in interval notation. When I do interval notation, I do small number to big number. Now you'll notice the different brackets here. These type of brackets don't include the value. So it's a rounded bracket when it doesn't include. It is a square bracket because it locks it in, which means it includes it. So see how we were less than 5? If we're less than 5, we're going to continue forever to negative infinity. So my minimum, my low number is negative infinity. My high number is 5. Now it can include 5, so I lock it in. You can't really ever reach negative infinity, so it's a rounded bracket. Same thing for my range, less than or equal to 7. So I'm going all the way down to negative infinity, never truly reaching it though, so I have a round bracket, comma 7 with a square bracket because it can equal to it. Now here's the difference between these graphs. I have a closed dot, which means it includes it. Here I have an open dot, so it's still 5 and 7, but notice it's not equal to, it's just less than. It's not equal to, it's just less than. So what I do here is I change my square brackets, which means it equals to rounded brackets. Okay, now let's look at above a number. So above a number, let's look at this endpoint. This endpoint is at -3 and +3. So -3 and +3. So I can see my x value starts at -3 and it gets bigger, so greater than or equal to -3. Or in my interval notation, from -3 up to infinity, square bracket, round bracket. The y value starts at 3 and just gets bigger, so greater than or equal to 3. Or using interval notation, 3 to infinity, close bracket for 3 because it includes it. Now similarly here, I have the same starting point, but it's an open dot, which means it doesn't include. So notice my equal sign goes away, my equal sign goes away, and both of my brackets here are rounded brackets. You need to feel comfortable with both ways of writing it, interval and inequality notation. Let's look at some other possibilities. You could have a graph that is in between two numbers. So if I'm in between two numbers, I'm just going to identify my coordinates. So -3 and 3, and then this point here is 5 and 7. So it's the same all the way through. I've done all the combinations you can come up with, both closed, closed and open, open, closed, both open. So you'll see that it's in between. So notice that my variables are in between the two numbers, the low number and the high number. So x is in between -3 and 5. So you can see x is in between -3 and 5. Because the dots are closed, it's equal to. You can see for your y values, 3 and 7, y is in between, literally in between 3 and 7, equal to because they're closed brackets. The interval notation, low number, high number, closed brackets for each because they're colored in. So you can see as I go along, all that changes is open dot means it doesn't include 5 and 7, rounded brackets for 5 and 7. Over here, it doesn't include -3 and +3, so no equal, rounded brackets for those. And this one doesn't include either, so notice there's no equal sign and both of them are rounded brackets. The last scenario you could have is where it goes infinitely in both directions. So if it goes infinitely in both directions, it's going to cover all of the numbers, all of the x values, all of the y values. That's why my domain is x is an element. That means it belongs to all real numbers. Or for interval notation, since it extends in both directions, it's -infinity to +infinity. Round brackets for both because you can't ever include or reach infinity. So those are all the different possible ways of writing domain and range. Let's end with a question that puts it all together. So in this question here, I have several parts. The first one, is this graph representative of a function? So what I'm going to do is I'm going to take a vertical line and I'm going to slide it along here and just see, does it only touch one time? And I can see it is only touching one time. So I can say it is a function because it passes the vertical line test. So yes, because it passes the vertical line test. Oh, let me try that again. It passes the vertical line test. Does this graph show discrete or continuous data? Because there's a line, it means it includes all of those values, so it is continuous because it is a line, which means the in-between points mean something. Okay, the domain. Let's identify our endpoints. So we're at -3, -2, -3, -2, and here we're at 5 and +3. Okay, so my domain is for x. It's in between -3 and 5. So for my domain, I'll do my interval notation. So it's the set of all x such that x is literally in between low number to high number, and then you do your inequality sign. I use equals because they are closed dots. I still add on that x is an element of the reals. So it's any real number between -3 and 5. Or in interval notation, it's between low number to high number, closed brackets for each because it includes it, it locks it in. Let's look at the range. So again, my points were -3 and -2, 5 and 3. So my range is the set of all y such that, now we're looking at our y values. Y is literally in between -2 and 3. So place y in between there with your inequality notations. Y is an element of the reals. Or in interval notation, you can say it's in between low number to high number. Lock it in for both. Okay, my last two questions are determining specific values. So I want to determine the range value when the domain value is -1.5. Domain value is along the x-axis. So if I look at when x is -1.5, that's right there, what is the range value? So I read down to the graph, and then I can read across and see that my range value is -1. So when x is -1.5, y has a value, or the range has a value of -1. Let's look at the next one. Determine the domain value when the range value is +2. So here's a range value of +2. I'll read over to the graph and down, and I can see that my domain value is 3.5. So I've introduced you to functions, domain, range, continuous, and discrete data. The most important thing to remember when you're talking about interval notation, if you're not part of the solution, then you're part of the problem. So I hope this video helped. If it did, give it a thumbs up and hit subscribe. And I look forward to seeing you for the next one.